A skeleton is found that is emitting 11 disintegrations of carbon-14 per minute per gram of carbon. Present day gives 15.3 disintegrations per minute per gram. When did the animal die? The half-life of carbon-14 is 5,730 years. Okay, so let's start by dissecting what we have. We have here 11 disintegrations of carbon-14 per minute per gram. That's effectively a concentration. And present day we have the same, another unit of concentration. So this is going to be our concentration initially, and this is our concentration at time t. Okay, we're also given a half-life, and we are asked for t, basically, a time. This one is phrased a little bit different than t, but if we find t, we can easily find when the animal died. Okay, now this is radioactive decay, so we can start with our first order rate law, which is the ln of the number of nuclei at time t equal to negative k, the rate constant, times time, plus the natural log of n naught. We have pretty much everything in here. We're solving for t, right? So this is our variable that we're solving for. We're given n naught, and we're given nt. We're given a half-life, though, instead of k, so we should find k from the half-life using the first order half-life equation. So we want k, we're given the half-life in years, so 5,730 years. So that means our k is going to be 0.00121 years. Now it's okay to leave it in years because we want to know when the animal died. Probably it was a long time ago, and so that is a reasonable unit to leave that in. Okay, then you can plug all those variables right into the equation as it is. I find it easier to rearrange the equation first for the variable that we want to solve for. So we can rearrange this by putting the natural logs together, negative kt, and then I'm going to switch the sides, and I'm going to divide both sides by negative k. Okay, we have all those variables, so the natural log of nt we had up here, so it's 11 disintegrations per gram per minute, divided by 15.3 disintegrations per gram minute, and then we're going to divide all of that by the rate constant, so disintegration cancels, grams cancel, minutes cancel, and we're just left with a unitless value, which we should be if we're going to be taking the natural log. Then, if you put that into your calculator, you get that time equal to negative 2727 years. That makes sense. It should be negative because the animal should have died in the past. This question specifically asked when did the animal die. So this is how many years ago it died. If we wanted to know when it died, right now it's 2020, so we would add the current year onto that, and we get negative 707 years, so that's going to be 707 years BC. And then we can look at our sig figs. So we are given 2 here, 2 here, 3 here, which means that a maximum this time here can have 2 significant figures, which puts it here. Answer is only accurate to the hundredths place from this one, so right here. So we can say the animal died around 700 BC.